Why are closed systems so important in thermodynamics? Imagine trying to understand how energy moves without worrying about outside influences. That's where closed systems come into play in thermodynamics. They help us focus on a specific part of a process without the complication of matter entering or leaving. Think of a sealed container or a perfectly insulated bottle. These are examples of closed systems because they allow energy to transfer in or out, but the material inside stays the same. In thermodynamics, a closed system is a group of connected parts that act as a single unit. The key point is that matter cannot cross the boundary of the system. However, energy can still flow through heat transfer or work done by or on the system. For example, when you heat a sealed metal can of water, heat moves into the water, but the water itself doesn't escape. This setup makes it easier to analyze what's happening inside. Why is this important? Because it simplifies the math and the understanding of energy flow. When you don't have to track matter moving in or out, you can focus solely on how energy changes form or moves around. This makes applying the first law of thermodynamics, which states that energy cannot be created or destroyed, much more straightforward. Closed systems are also used in real-world applications. Think about a thermos bottle. It keeps your coffee hot by transferring heat in or out, but the coffee stays inside. Or consider a pressure cooker with a lid. It allows heat to transfer but keeps the contents sealed inside. These examples show how closed systems help us control and understand energy transfer in everyday life. Another reason they matter is because they help us understand the idea of energy conservation. Since no matter enters or leaves, any change in the system's energy must come from heat or work. This helps us see how energy is conserved and transformed within the boundaries. Closed systems also help explain concepts like equilibrium and entropy. When a system reaches equilibrium, there's no net energy flow. Over time, entropy or disorder tends to increase until the system stabilizes. This understanding is essential in many fields, from physics to engineering. In summary, closed systems are vital because they give us a clear, manageable way to study energy transfer. They help us see how energy moves and changes without the added complexity of matter crossing boundaries. This makes the principles of thermodynamics easier to grasp and apply, whether in designing engines, understanding natural processes, or improving energy efficiency.